Hello, and welcome to our second Professional Development Hangout. In this Hangout, each individual will discuss different emerging technologies and how to use them in the classroom by applying the SAMR model. The SAMR model is used by educators when trying to infuse technology into teaching and learning. The four levels of SAMR include substitution, augmentation, modification, and redefinition. Each of these stages in SAMR involve a different framework on how to integrate technology into teaching and learning. With the help of Kathy Schrock's Guide to Everything, we will be able to discuss the topic augmented and virtual reality in the classroom, which is the category I have chosen. Within this category, I go into explaining the two tools of Erasma and CoSpace's Maker. Next, we will have Savannah discussing the tools Scratch Junior and Tinker under the category of coding and programming. And finally, we will have Kara wrap up our discussion by discussing the tools Google Slides and Google Forms under the topic Google Tools. Let's start with augmented reality in the classroom. Confused on what augmented reality is? Don't worry, I'll explain it to you. Augmented reality is a live, direct or indirect view of a physical, real-world environment whose elements are augmented by computer-generated sensory input, such as sound, video, and graphics. Let me put that in simpler terms for you. Augmented reality is simply a digitally enhanced view of the real world, blending digital information with real-world spaces. One augmented reality tool loved by many is Erasma. It is also the tool I will be discussing right now. Erasma was created by the Hewlett-Packard Development Company, with R.J. Holmberg being the Director of Business Development for the HP software Erasma. To find out more information, one can go to Erasma's very own newsletter, or one can find information via their Facebook page, YouTube channel, or Twitter account. The purpose of augmented reality tool Erasma is to provide a new way to see and interact with the world. Erasma's goal is to help people use augmented reality to turn everyday objects, images, and places into new interactive opportunities by engaging through striking graphics, animations, video, audio, and 3D content. Erasma is a simple-to-use tool. This is due to the fact that it provides users with user-friendly tutorial videos explaining step-by-step procedures on how to do anything pertaining to Erasma. This tool provides so many different possibilities when it comes to the use of the tool. Some possibilities include, but are not limited to, the creation of personalized augmented realities, known as auras, the ability to share these personalized auras, viewing other auras made by other people all around the globe, and even the option to provide feedback and ask questions directly related to specific auras or Erasma as a whole. Erasma can be applied to the SAMR model. Let's start at the beginning with substitution. Instead of teacher demonstrating the concept of telling time on an analog clock and then proceeding to have the students complete a worksheet to check their knowledge on what they learned, the teacher can instead allow the students to work in pairs and use Erasma to watch different instructional videos to explain how to tell time before completing the worksheet. There is no functional change here. Regardless, the students would be given instruction on how to correctly tell time. In this example, Erasma is simply being used as a direct substitute on how the students receive the instruction. Next in the application of the SAMR model is the process of augmentation. A teacher may have students create handwritten flashcards of their weekly spelling words, with each spelling word on one side of a flashcard and a drawing of a picture to explain the meaning of the word on the other side. Instead, a teacher can have students use Erasma to make flashcards of their spelling words. Each spelling word can be written on one side of the flashcard, but instead of drawing a picture on the other side, the students can use Erasma to link each word to a video or a picture that they found to depict the meaning of each spelling word. The teacher may then proceed to having the students trade their flashcards and study a peer's flashcards, which is linked to different things in Erasma. Moving forward in the application of the SAMR model, we come to modification. When teaching the alphabet, instead of a teacher giving verbal assessments on why each letter in the alphabet has a different corresponding picture provided on the alphabet strip, the teacher can have the students go on a scavenger hunt in small groups, with each group using Erasmus to link each letter in the alphabet to different pictures of different classroom items, which the students feel represents each letter. The students are still learning the letters of the alphabet, but by using Erasmus, the students are able to enhance their learning of the alphabet. The last application of the SAMR model is the process of redefinition. Teachers may have students perform a typical research project, which includes finding research on the internet about a chosen topic and submitting the work in a systematic, laid-out way. Instead, teachers can have students choose a topic to research for a project and use Erasmus to find real-world data and examples pertaining to their topic. The students will create their project using augmented reality within the tool Erasmus. Once finished, the students can have their peers view and comment on their projects through the use of the tool of Erasmus as well. The act of the students finding real-world examples and presenting them in their project could not have been done in a traditional research project. It was only able to be done with the use of Erasmus. The students presenting their project as an augmented reality could not have been accomplished without Erasmus as well. To wrap things up, let's talk about the positive and negatives of using Erasmus in the classroom. The tool Erasmus should be used in the classroom for many reasons. Provided are just a few reasons why Erasmus should be used. Erasmus provides students with an alternative way of looking at the world and education concepts. If Erasmus is used in the classroom, students who do not understand a concept can use this tool as a means of understanding. Erasmus allows students to think outside of the box when it comes to learning in the classroom, giving inspiration for learning along with providing a creative and fun way to learn. Erasmus is used by more than 100,000 people who have provided other users of Erasmus real-world feedback. A constraint that comes with using Erasmus and augmented reality is that some students or schools may not have access to the technology needed to process Erasmus, examples being iPads or smartphones. Another constraint includes the possibility of distraction when using Erasmus, considering all it has to offer. Visit the reference section listed if interested in learning more about Erasmus or augmented reality. Now, let's talk a little bit about virtual reality. Similar to augmented reality, but also completely different. Virtual reality is a believable, interactive 3D computer-created world that you can explore so you feel you are really there, both mentally and physically. Virtual reality is essentially believable, interactive, computer-generated, explorable, and immersive. The virtual reality tool we will be discussing now is CoSpaces. There are two versions of CoSpaces, one being CoSpaces Maker and the other being CoSpaces EDU. CoSpaces Maker is free and available for anyone and everyone, whereas CoSpaces EDU is not free and only available for teachers and students. Therefore, we will focus on discussing CoSpaces Maker. The virtual reality tool CoSpaces Maker was created by a team known as Delightex. Eugene is the founder as well as CEO of Delightex. Some other notable team members include Manuela, who is the head of marketing, and Thomas, who is the head of UX. These are just a few of the members who make up the team. There are many members that make up this team as well. To find out more information about each of these members, or Delightex as a whole, visit the link provided on the About section within the website CoSpaces Maker, or you can contact them via email, which is also provided under this section. The purpose of CoSpaces Maker is to allow users to create their own virtual reality worlds and bring them to life with the power of code. CoSpaces Maker is a very simple and easy-to-use software. This is because it can be operated across all platforms, ranging from laptops to smartphones to tablets. This tool also provides users with detailed step-by-step instructions on how to make their own virtual worlds and how to explore those worlds created by others and themselves. It provides the users with all the tools necessary to make, code, and explore their own virtual reality and 3D creations. Now that we have a basic understanding of what CoSpaces Maker is, let's apply it to the SAMR model, starting from the beginning with substitution. When students come back to school after summer vacation, Teachers may ask the students to draw a picture on poster board with crayons or markers detailing what their favorite part of the summer was. Instead of having the students draw on poster board paper, the teacher can allow the students to use CoSpace's Maker to create a virtual world containing the student's favorite part of summer. Now that the students are still expressing the same idea, but in a different way, going from pen and paper to virtual reality. Now we will move into the augmentation step of the SAMR model. Teachers can have students use CoSpace's Maker to build a world to describe a scene from a book. Instead of the teacher reading a book to the class and periodically asking questions about the content of the book, students can use CoSpace's Maker to portray one specific scene in the book. Each student will get a different scene in the book to explore. After the students have created the world that they feel best represents the scene they had in the book, each student can share with their peers the world they created in CoSpace's Maker. When the students use CoSpace's Maker to depict a world based on a particular scene in a book, the students are using technology as a means of functional improvement. Now let's proceed with the next step in the SAMR model, which is the process of modification. Instead of the teacher giving the students addition and subtraction worksheets to evaluate their knowledge, the teacher can have the students work in pairs to create a game on CoSpace's Maker about adding or subtracting numbers. The students will work in the JavaScript and TypeScript coding domain to create the game. Once all the groups of students are done creating and saving their games, they can move on to playing the games that they created by their peers. After each pair of students plays one of their peers' game, they can provide a rating on the effectiveness of the game through CoSpace's Maker. The outcome of assessing the students' knowledge of addition and subtraction problems is the same throughout, but the act of them using CoSpace's Maker to create a game to demonstrate their knowledge provides a significant task redesign. This modification involved getting the students a different kind of assignment while still having the same outcome. Finally, we have the process of redefinition, the last step in the SAMR model. Instead of teaching fire safety hypothetically to students, teachers can have students practice fire safety by encountering an actual fire through virtual reality. The teacher can start by having the class as a whole take turns in creating an elaborate 5-story house with the use of CoSpace's Maker. Each student will enter the house via virtual reality and go through a simulation where the house catches on fire, and there is a limited amount of time for the student to exit the house safely. Each time the simulation runs, a different part of the house will catch on fire, therefore simulating the unpredictability of fires. Each student is required to practice what they know about fire safety within this simulation. Without the use of CoSpace's Maker and virtual reality, the students would not have the opportunity to encounter a real-life situation without actually having to go through the situation in real life. That concludes our application of the SAMR model for the tool CoSpace's Maker. Let's move on to some advantages and disadvantages one may encounter when using CoSpace's Maker. CoSpace's Maker should be used in the classroom for a multitude of reasons. Some reasons including it allows students to reach beyond their imagination and create whatever they like in virtual reality or in 3D. It provides students and teachers with an easy understanding of virtual reality and becomes accessible for all students, including kindergarten students. It also provides any user, whether it be a teacher, student, or just someone with a creative imagination, with many different ways of accessing information based on how to do something within CoSpace's Maker. It allows users to explore different virtual worlds created by others, while also having users to share the virtual worlds they created. There are also some constraints when using CoSpace's Maker. One constraint of this tool is that it requires users to have access to an email in order to create an account. Without access to an email, a user cannot create an account, meaning there is no opportunity for that user to create and explore with CoSpace's Maker. This tool falls under the marketplace, where users are provided the opportunity to purchase different assets in order to create a virtual world. The constraint is most of these assets cost coins, which are only available through the purchase of vouchers. Many users, students and teachers included, may not have the funds to purchase vouchers, meaning they become instantly limited in terms of the amount of creativity they're able to express when creating their virtual worlds in CoSpace's Maker. To learn more about virtual reality and CoSpaces Maker, visit the references listed. Now, let's hear from Savannah.
The technology from Kathy Strock's guide that I researched is coding and programming. Coding is a system of signals used to represent letters or numbers in transmitting a message. Programming is the act of implementing a code. It is the primary method of communication between humans and machines. Coding is used by computer scientists. However, with the demand for jobs in the field at an all-time high and technology rapidly taking over the workforce and schools, it is important for students to become well-versed in the world of computer science. Coding and programming are everywhere. The computer or device that you are watching us on, the tool we are using to record, and the smartboards, tablets, apps, and games our students use every day run via code. The first coding and programming tool that I chose to research is called Scratch Junior. Scratch Junior is a collaboration between the DevTech Research Group and the Child Study and Human Development Department at Tufts University, the Lifelong Kindergarten Group in the MIT Media Lab, and the Playful Invention Company. Scratch Junior is designed for children 5 to 7, while its parent company, Scratch, is for ages 8 and up. You can find out more about the design team on the About page at scratchjunior.org. Scratch Junior, like Scratch, is an introductory programming language designed for children 5 to 7. Children are challenged to program their own stories and games. The tutorials on Scratch Junior are self-led, so students can learn at their own pace. They are also designed for students ages 5 to 7, so they are on track with the ability of the children at that age. In my classroom, I would use Scratch or Scratch Junior during story time to enhance engagement. We could make a story as a class and then read it aloud. Now for applying the Sammer model. In substitution, teachers can use Scratch Junior when reading aloud to students instead of using a paperback book or a hard copy. Story and read it aloud to the class on Scratch Junior. For augmentation, teachers and students can collaborate on a Scratch Junior story of their own and read it aloud as a class. Modification, teachers can create a story and read it aloud to the class on Scratch Junior. Then students can attempt to retell the story with their own programming. Teachers can check each student's comprehension of story dynamics, such as character recognition, beginning, middle, and end of a story, and problem solving. For redefinition, students can work together to program their own stories. In conclusion, Scratch Junior is an age-appropriate, scientifically backed in design, and it allows students to address problem-solving skills and story development skills. The strength of Scratch Junior is the reported glitches that could interfere with class time. The second coding and programming tool that I choose to research is Tinker. It doesn't disclose on their site who specifically is a part of the design team, but they refer to those individuals as the Tinker team. I have a list of investors who support Tinker. More information about the team and its investors can be found on this page on the Tinker site. Tinker is a learning system that teaches kids how to code. Eventually, they are tasked with designing games, apps, and making projects. Site. Tinker asks students how much they have coded before, and based on their response, the tutorial caters to the assistance of their needs. It does require an account to use, but the basic accounts are free. Tinker is for the specifics of coding and programming learning, offer grade and level specific curriculums for the teachers to teach code within subjects. Now for applying the Sammer model. substitution, teachers can use the basics of programming lessons and courses that Tinker supplies to teach students how to follow basic directions. For augmentation, teachers can use this programming again to teach the basics of following directions, but then teachers can create a false code, or one that does not carry out the intended function, and have students find the error within the code. For modification, teachers can have students work through the subject lessons on Tinker, like science, for example, during that subject period in school, to teach both coding and that subject. In addition, teachers can ask students to code their own projects using Tinker. This way, students are studying the content and practicing code. In conclusion, Tinker teaches students coding within the basic curriculums already taught in schools. There's curriculums specific to teaching coding, tutorials to suit each student's specific ability to code. Is that any lesson offered beyond the basics of coding must be paid for within an account. Teacher to pay for these on their own can be pretty costly. To learn more about these tools or coding and programming, here are the references for Scratch Junior and Tinker. Now on to Kara to discuss Google Tools.
I decided to research Google Tools. The first Google tool that I researched is called Google Slides. Google Slides was created by the company Google. The program was released in January of 2010. Google Slides offers many features. It is a presentation software that allows the user to create, edit, and collaborate with other people to make a presentation. This software is free to use. Google Slides allows the user to create their own slides or choose from a number of templates that Google offers. Now let's apply this tool to the SAMR model. First is substitution. Have students use Google Slides to create a presentation on a given research topic. Students are able to show the online presentation in class instead of creating a handwritten visual and printing out images. Next is augmentation. Have students do group work using Google Slides. Students can collaborate their ideas using one common presentation. Everyone can work together on the same presentation at the same time. Students can all participate and input their thoughts on an assigned part of the project, and then present all their ideas to the class together. Next is modification. Students can incorporate interactive multimedia into their presentations. They can add images, hyperlinks, videos, and animations to their presentation to make it more engaging for the audience and to add more depth to their research. Finally, redefinition. Teachers can use Google Slides to teach their lessons. They can create a presentation that follows their lesson plan so that it can be easily presented to the class. This allows a visual aid that is easier to follow rather than a written copy of a lesson plan. In conclusion, Google Slides has a lot to offer. The program saves your work automatically after every change you make so that you don't have to worry about your device crashing or turning off. You can also access your slides from anywhere and on multiple devices. Finally, there are hundreds of options when using Google Slides, including the slide layout, the font, different colors, and adding multimedia and more. And it gives you the freedom to be creative. Although this is all great, you must have a Google account to use Google Slides. The second Google tool that I chose to research is called Google Forms. Google Forms was also created by the company Google. This program was released in February of 2007. Google Forms is a free software that allows you to collect and organize any information, big or small. It allows the user to create surveys and quizzes as well. Now, let's apply Google Forms to the SAMR model. First is substitution. Students can use Google Forms to collect data for research. Input data as survey responses and create a pie chart to view the data. The students can use this to present their research to the class. Next is augmentation. Teachers can use Google Forms to create a multiple choice quiz. Students can access the quiz on their own device and take it in class. Teachers can then gather information from the quiz and make changes to their lessons depending on the results. Next is modification. A teacher can place a student/parent information form on their school website so that all families have access to it. Instead of sending home a paper copy with the student, have students and parents access the forms online and fill them out. When done, they can click submit so that it can be sent directly to the teacher's email, and the form does not have to be handed in person. And finally, redefinition. Teachers can have students complete an exit ticket using Google Forms. When the lesson is over, each student must complete the exit ticket. It can consist of a variety of questions, such as multiple choice, short answer, and long answer. This will be graded automatically so that the teacher does not have to grade each one individually. In conclusion, Google Forms is an easy-to-use software that allows you to collect data and save it all in one place. There are many different versions and templates to choose from when creating a Google form. You can also add images and videos to your form, which allows for personalization. As well as Google Slides, you must have a Google account to use Google Forms. Also, some students may have difficulty filling out some of the forms on their own, so they may need a parent to help them. These are the references I use to gather information about these Google tools. This concludes our second professional development Google Hangout. Hopefully, you can integrate these technologies into your classroom. We hope you found this useful. Thank you for watching, and be sure to tune in next month for our final Hangout.